Thank you, Prahadi. Um, okay. So, hi, good evening, everyone. Thank you for joining today's speaker session. So, I'm Chamodi Karunatunga, and I'm really happy to be here with you all today. So, as you all know, we are going to talk about data engineering essentials. I know data can sound very complicated, but I promise we'll keep it straightforward and interesting. So, whether you're just starting out or looking to refine your understanding, I hope you all will leave this session with a clearer idea of what data engineering is all about and how it ties into the bigger picture of data-driven decision making. So yeah. So, all right. Here's what we have lined up for today. We'll kick things off with a small, simple introduction to data engineering, what it is and why it's so important. Then we'll explore data warehousing and how large-scale data is stored and organized. And after that, we'll touch on big data and why it's a game changer, followed by a look at cloud how cloud solutions are transforming data engineering. And next, we'll look into Microsoft on-prem platform to see how it supports data engineering and business intelligence. Finally, we'll wrap up with a practical demonstration to bring these concepts to life by developing some ETLs, a data warehouse, and a multidimensional cube for analysis. So, mix of theory in the first half and hands-on learning in the second. So let's get started and yeah, let's jump in. So yeah, so introduction to data engineering. Let's start with this. So why data engineers came into the picture. Let's take a quick journey through the time to understand why data engineers are so important today. So picture this, a time before big data, cloud storage, or even the flood of information we see online every day today. Back then, businesses did not have nearly as much as data they do now, just a small fraction of what they deal with today. So fast forward to today, and it's a whole different story. Every click, every transaction, and every customer interaction generates huge amount of data, and it's coming in at a staggering pace. So in the early days, it was mostly IT teams managing data, but as businesses realized just how powerful data could be for making decisions, they needed more than just storage. So um, they needed experts who could make sense of all this raw information. That's when the role of data engineering really started to take shape. So, data engineers became the go to experts for handling the growing amount of data, turning it into something useful that helps businesses to grow and make better decisions. So, it's not just about collecting data, it's about cleaning it, organizing it, and making sure it's ready for analysis. So, while traditional IT roles like database administrators handle the technical side, data engineers specialized in building data pipelines, integrating systems, and ensuring that data was flowing smoothly from one place to another, all while keeping it clean and accessible. So today, data engineers are like the bridge between raw data and actionable insights. So without data engineers, businesses would struggle to make the most of massive amount of data they collect every day. And with the explosion of data we see now, data engineering role has only become more important. So what is data engineering exactly? So it's all about building systems to handle data, collecting it, storing it, and processing it so it's ready to be used. Data engineers make sure the data is clean, well organized, and easy to analyze. So we set up the pipelines that allow data to flow
Extremely sorry for the technical difficulties. Can you please give us 2 minutes?
All right, sorry about the technical issue. So let me share my screen again. All right. I hope you all can see my screen. Yeah. So I was telling what is data engineering all about. So I'm not sure whether you all heard it correctly. So I'll anyway start from this onwards. So So I was telling like what is data engineering. So actually it's all about building systems to handle data, collecting it and storing it and processing it so that the others can use it properly for their analysis and stuff. So data engineers actually make sure that the data is clean, well organized, and also in an accessible way to analyze. So we normally set up all those pipelines that allow data to flow very smoothly and be ready for decision makers to use. So to tell all you simply, we take raw data and turn it into something useful for businesses to make smart choices. So as data engineers, our main tasks are pretty straightforward. We build and manage data pipelines to make sure data moves efficiently from one place to another. So we integrate data from different sources, bringing it all together in one spot. Once collected, we store data in accessible format so it's easy for others to use. We also clean and transform data to ensure it's ready for analysis, removing any errors or inconsistencies. So lastly, we automate processes to keep the data fresh and up to date. So our goals focus on making sure the data is accurate, clean, easy to access, and ready for analysis. So these four things are key to making data useful for decision making and turning it into valuable insights. So, all right. So why is data engineering such a big deal? So I explained briefly earlier as well. Um, but again, I'll explain a bit more. So data engineers helps in data-driven decision making. So we make sure the data is clean, accurate, and ready to go. So the businesses can make smart decisions based on solid facts, not just the gut feeling. So, and also, this is the foundation for data science, analytics, and AI. So, without data engineers, data scientists, and AI wouldn't have the clean data they needed to do their thing. So, data engineers are like the builders of the data world. So, then automate data processes. So the data engineers build systems that automatically handle a lot of heavy lifting like collecting and cleaning data. So people don't have to do it manually all the time. So and also it has a scalable infrastructure. As data keeps growing, we make sure the system can handle the extra load no matter how much data comes in. The system should keep running smoothly. So, and the other one is ensure data quality. So, data engineers clean up messy data, check for all the errors, and make sure everything is structured properly so the data is ready for others to use. So, yeah, data engineers are the ones who make sure everything runs smoothly and the data is ready to be used in all those cool ways to drive business decisions and innovations. So, let's talk about the tools that every data engineer should have in their toolkit. First up, programming languages. So don't worry, we don't need to code full time like software developers. Anyways, the most frequently used ones are Python and SQL. So you might also come across Java or Scala in some projects. Next, database systems. So data engineers work with both relational databases like SQL servers, MySQL, and PostgreSQL, as well as NoSQL databases like MongoDB and Cassandra, depending on the type of the data, actually. So Then we have ETL tools. Tools like SSIS, Apache Airflow, and Talent help us extract, transform, and load data, essentially moving data from its source to its destination. So when it comes to data warehousing, we use tools like Redshift, Snowflake, Google BigQuery, or even SQL Server Analysis Service. Uh, Again, it's called SSAS. So, and then for data orchestration, tools like Apache Flow, Luigi, and SQL Server Agent are used to automate workflows and ensure data flows smoothly across systems. So moving to the cloud, AWS, Azure, and GCP are key platforms for storage processing and computing in cloud-based environments. So for handling massive data sets, big data frameworks like Hadoop, Spark, and Kafka are used. And finally, Git version controlling. So as you can see, data engineering involves a mix of programming, database management, cloud platforms, and big data tools, all working together to handle data effectively. Then let's clear up the misunderstanding between data engineers, data scientists, and data analysts, because a lot of people get them confused. So, data engineer. So, think of them as the architects of the data world. They build and maintain all the systems that make data flow smoothly, like setting up pipelines and databases. Their job is to make sure data is reliable, accessible, and ready for other roles to work with. Then data scientists. So these are the data geeks who dig deep into the data to uncover hidden patterns and trends. They build models and use tools like machine learning to predict what's going to happen next, helping businesses to make smarter, future focused decisions. Then there's data analysts. So these guys are the ones who turn data into stories. They look at current trends, create reports, and make data easy to understand for business teams while helping them to make business decisions based on what's happening right now. So basically, data engineers prepare the data, and data scientists explore and experiment with it, and analysts interpret it for decision making. So simple, right? Yeah. Okay. Moving forward. Um, yeah. uh, Data engineering in the context of the data lifecycle. So, data engineering involves managing data through every step of its lifecycle. So, from data collection, where we gather data from various sources, to data storage, where it's organized and stored securely. We then move on to data processing and cleaning and transforming it for future use. And then once the data is ready, data analysis and data visualization help uncover insights and make the data meaningful. So we also handle data archiving and retention, ensuring we keep data as needed and focus on data security to protect sensitivity information throughout the process. So then um, now let's dive into data warehousing. Okay, so in simple term, what is I'll answer to this question in simple terms. A data warehouse is like a large storage space where data from various sources is collected, organized, and stored for analysis. Unlike traditional databases, which store data for everyday operations, a data warehouse is specifically designed for reporting and analysis. So it helps businesses store historical data in one place, making it easy to analyze and gain insights. The data is cleaned and organized to make it easy for analysis to work with. And then it's especially important for companies that need to handle a lot of data and use it for long-term analysis to make smart and informed decisions. So, all right. So here's a fun but important comparison on two concepts of data systems. So OLTP, online transaction processing. So this is like the engine behind all your daily transactions. It handles real-time updates. Think of it as the system when you're shopping online, booking tickets, or making bank transfers. So quick, efficient, and always live. So the other thing is OLAP, online analytical processing. On the other hand, it is like a data detective, I would say. It looks like a large chunk of past data to find trends, patterns, and insights. When businesses need to forecast sales or track long-term trends, they turn to OLAP for powerful analysis. So data warehousing actually falls under this category of OLAP. And so OLTP is the speeds up for day-to-day tasks, and OLAP is the brainiac for deep data analyst. So then, um, a key characteristics of data warehouses. So a data warehouse is built to store business data in an organized way. So it focuses on important areas like sales or customers, making it easy to analyze. So it brings data from different sources together. So everything is in one place. It also stores data over time and helping you to track trends and changes. So once the data is in the warehouse, it stays the same, ensuring consistency for reports. And because it's structured for fast access, running reports and getting insight is quick and easy. And then, so these features make data warehouse ideal for analyzing a large amount of business data. And yeah, so let's walk through the basic structure of data warehouse architecture. So first we have data sources where the raw data comes from, like transactional systems or external files. The data then enters the staging area, which is like a temporary holding space. Here's the uh, here the data is cleaned and transformed to make sure it's in the right format. After that, the clean data moves using ETLs into the data warehouse area, which is where it's stored in a well-organized, structured, and ready for analysis way. Then the data warehouse area holds large amount of data from across the business. Now, for specific departments or teams, we might have data marts. These are smaller, more focused sections of the data warehouse that store data for particular business areas like sales, inventory, marketing, finance. So they make it easier for teams to access the data that's most relevant to them. Finally, the data presentation layer. So, um, so this, so finally, this presentation layer actually that is where make all these data accessible through reports or dashboards, allowing users to analyze and gain insights quickly. This structure makes sure that data is collected, cleaned, stored, and presented in a way that helps businesses to make decisions. Okay, so let's quickly compare what is data warehouses and data lakes. A data warehouse is like well-organized library. It stores structured data like tables and rows that's been cleaned and pre-processed in advance. It's perfect for analysis and reporting. So think of it as the go-to place for business intelligence. On the other hand, a data lake is more like a massive storage pond. It stores everything structured, semi-structured, and unstructured data. So you could have anything from logs and videos to text files there. So data is dumped in a raw form and only processed when it's needed when it comes to data lakes. So it's ideal for big data analysis, machine learning, or anything that needs real-time processing. So when it comes to the cost in terms of um like costing and maintenance, data warehouses are more expensive due to the structure, while data lakes are cheaper because they store raw data. So briefly, data warehouses store clean, ready to analysis data, while data lakes store lots of raw data for deeper insights later. So then Let's talk about the key benefits of data warehousing. So, first off, it helps businesses to make better decisions by providing organized, accurate data for real insights. It also improves reporting, making it easier to create clear and accurate reports, saving time. So, the data is clean and standardized, ensuring quality and consistency as well. Plus, it allows for faster data queries so you can quickly find what you need. As the business grows, the data warehouse can scale with it, storing more data without slowing down. And you can store historical data, making it easy to track trends and analyze past performances as well. So basically, data warehousing helps businesses make smarter decisions with reliable and easily accessible data. So yeah, so while data warehousing brings a lot of benefits, it's not without its challenges. First, bringing all your data together smoothly can be tough, and ensuring it's accurate is key. As the data grows, performance and cost can become an issue, and security becomes even more important. You also need to plan for scalability as your business grows. Plus, keeping everything running and getting users on board can take some work. But once you get past these hurdles, the rewards are definitely worth it though. So, yeah. So now let's talk about big data. It's like the next step in the data evolution. So as businesses and technology grew, so did the amount of data. We are talking about massive volumes of data. Think billions of transactions, social media, posts, sensor data, and much more. This is where big data comes into play. So traditional tools just can't keep up with that anymore. So big data needs special tech to store, like special tech to store, process, and analyze it in real time, helping businesses make smarter decisions. It's a massive game changer that's pushing the boundaries of what we can do with data. Yeah. So what is big data? Um, I'll explain it like this. So imagine a flood of information coming at you, so much that it's hard even to keep track of it all. So that is big data. It's data that's too massive, too fast, or just too complex for traditional tools to handle. Think about all the things generating data every second: social media posts, online shopping, GPS signals, sensors in machines, and even smart devices in your home. So, all of this adds up to big data. It's not about just size, it's the speed and variety of data that makes. Oh my God, it's still there. Yeah, right. Sorry about all the problems. We actually need some time. There's a power cut over here. All right. Hope you all can see my screen again. Right? Can you? Okay. And so I was actually telling like what is big data. And so in simple terms, big data is like the information explosion. So it's bigger, faster, and more complex than anything we worked with before. So then characteristics of big data. To understand big data, we often talk about the 5 A's, the key characteristic that defines it. So So, volume. So, this is the sheer size of data. We are talking about petabytes and exabytes. So, it's like trying to manage the entire library of human knowledge, but in a digital form. And when it comes to velocity, data is being generated and at lightning speed, I would say. So think about how fast social media post, online transaction, or sensors regarding uh, sensors like are created. So it's coming at us in a real time. So so big data comes in all shapes and sizes, structured like tables, unstructured like text or images, and semi-structured like logs. So it's a mix of data from very direction. That is what we call it variety. So when it comes to veracity, not all data is perfect. Some of it is messy, uncertain, or incomplete. So veracity is about making sure we can trust the data, even it's not always 100% accurate. So ultimately, big data is all about finding the value hidden with it. So it's not just about collecting data, it's about uncovering insights that can drive decisions and business success. So so the 5 E's are what make big data so exciting and challenging. So the size, speed, variety, trust, and potential, value it holds. So these are some of the key big data technologies we have: Hadoop, Apache Spark, Apache Kafka, NoSQL databases, Google BigQuery, Amazon Redshift, Apache Flink. So I won't go into details about each one because like the time is not enough. And this is a very big topic. So, but these technologies are critical for storing, processing, and analyzing massive data set at scale. So yeah, so bi- uh, big data is actually not just a buzzword, it's changing the way the world works actually. So here are three cool ways it's being processed. So first one is predictive maintenance. So imagine your car warning you before the engine breaks down, or a factory detecting when a machine is about to fail. That's big data in action. So sensors collect data and algorithm predicts when something is about to go wrong, saving tons of money on repairs. So the second one is personalized recommendations. So ever wondered how Netflix always seems to know what movie you're in the mood for, or how Amazon or AliExpress just suggest just the right product? So big data tracks your behavior, predicts what you'll love next, making everything feel custom tailored just for you. Then there's smart cities. So picture a city that knows when to adjust traffic lights, reduce energy consumptions, or dispatch emergency services. So before you even ask, actually. So with big data, cities are getting smarter, using real-time data, make life easier and safer for everyone. So big data is everywhere, turning everyday experience into something smarter, faster, and more efficient. So, um, so let's dive into how the cloud has totally changed the game of the data engineering. So in the old days, managing data meant dealing with bulky servers, expensive hardwares, and tons of headaches. But now, with cloud platform like AWS, Azure, and GCP, everything is a lot simpler. You don't need to worry about owning physical infrastructures anymore. The cloud offers some huge advantages for data engineers. So, if you want more storage or power, no problem. Just scale up without worrying about buying new equipment. And then automation. So cloud tools let us automate tasks like data ingestion and cleaning, saving time and reducing errors. And then you get access to cutting edge tools for analytics, machine learning, and real time processing without having to shell out for expensive hardwares. So basically, cloud computing has made data engineering more flexible, cost effective, and packed with powerful features. So, cloud platforms have completely transformed data engineering. So, instead of worrying about maintaining servers and hardwares, engineers can now focus on building data pipelines and analytic processes in cloud environment. So here are some of the top cloud platforms that are commonly used in data engineering. So AWS is one of the most popular cloud platforms, offering a wide range of services like S3 for storage, Redshift for data warehousing, and Glue for data integration. So AWS provides a flexible environment for data engineers to work with big data and machine learning. So when it comes to Microsoft Azure, Azure offers tools like Azure Data Lake and Azure Synapse Analytics for managing large data sets. It integrates seamlessly with other Microsoft tools, making it go-to choice for companies already using Microsoft products. So so GCP provides powerful tools like BigQuery for fast data querying and Cloud Data Flow for stream and batch processing. So it's known for its ability to handle big data and its advanced machine learning capabilities. So each of these platforms has its own strengths, but all offer scalable, flexible, and cost-effective solutions for data engineers. Right. So here let's dive into the Microsoft on-prem platform for a moment. So it's clear that cloud tech is the current rock star, but on-prem solutions are still holding strong. Why? Well, many businesses stick with on-prem because it gives them full cover over their data, especially when privacy and security are top priorities. For companies dealing with sensitive information or strict regulations, keeping things in-house just makes sense. So, understanding these on-prem tools is key to grasping how data engineering works, and especially when it comes to maintaining that delicate balance of security and compliance. So, yeah, so Microsoft on-prem tools like SQL servers, SSIS, SSAS, and SSRS are key for managing, processing, and analyzing data within a company on-site. So these tools help build strong data pipelines, integrate data, and manage data warehouses. So SSMS, SQL Server Management Studio. So think of SSMS as your control center for all things in SQL Server. So it's where you manage and keep track of everything happening in your databases. Then SSIS. So that is SQL Server Integration Services. SSIS is it's your go-to tool for building data pipelines. It grabs data from different places, transforms it, and loads it where it needs to go, making sure everything flows smoothly. Then SSAS, SQL Server Analysis Services. So SSAS is like a data detective. It helps you analyze data by creating OLAP cubes and complex models, helping you dig deeper and find hidden insights. So then there's SSRS, SQL Server Reporting Services. So once the data is ready, SSRS bring it to life with reports and visualizations, making complex information easy to digest for everyone. Right. So now, to give you a better understanding of how these tools come together in practice, I'll quickly walk you through a demonstration of an on-prem data process. So you'll see how Microsoft SSMS, SSIS, SSAS, and SSRS, and maybe Power BI work in hand to manage and transform, analyze, and visualize data. So this will give you a clear picture of the data engineering process and on-prem platform. But today I will not be explaining how to install and configure these tools. So you can find a lot of materials for that in the internet and YouTube. So let's start then. Right. So, okay. So, So this is the data warehouse architecture. I think I explained this earlier as well. So we are having all those data sources coming from different sources like Excel's, maybe data, other Oracle databases or JSON files, things like that. And then we get all of these sources to a staging area. So that is where we place all those raw data. And then using ETLs, and after doing all those transformation, we put them to data warehouse. And then this data mart. So this data mart part I won't be doing today because I will be just focusing on the data warehouse and then how to give it as a cube and then how to connect it to the representations, visualizations. So, right. So I'll show you my SQL Server Studio. So we'll start from there. Right. Hope you all can see my SQL Server Management Studio. Right. So, so first of all, like we need to create a connection. Like once you configured SSMS, you just have to uh, just connect it. Uh, Here we have a lot of options: database engine, analysis service, integration service, reporting service, and everything. As I mentioned earlier, this is like the main controlling part. So here at the moment, at first, what I want is database engine. So I'll be just connecting it to the engine. So I have actually already connected, so I will not be connecting again. So this is how you connect and configure. So, and then after that, in order to create a data warehouse, we need two databases, staging database and data warehouse, as I explained before. So staging data um base is to uh, store raw data. So what we can do is we can like right click on databases and then create new database and then give the database name you want. And then you can click OK. If you want any other configurations, you can do it from here. But basically, like this is enough. So since I have already created that, I will not be creating this again. So the same way, do the like create the staging and data warehouse databases. And then, so before moving forward, there are some concepts that we need to go through to understand the processes. So let me go back to the slides. Right. So in dimension versus measures. So in data warehousing, dimensions and measures are key concepts that help structure um, and analyze your data. So dimensions, what are they? So basically, dimensions are descriptive attributes or categories that you use to slice and dice your data. They provide context for your measures. For example, in an e-commerce data warehouse, dimensions could be things like customer, product, time, or location. So they help to group or filter data in a meaningful ways. For example, you might want to know how many products were sold in a specific time period or which products were the most popular in a region. So then there's measures. So they are the numeric values of matrix, and that is actually what you want to analyze. So these could be things like sales, revenue, quantity sold, or profits. So as mentioned earlier, measures are the data you actually want to analyze. They represent quantitative data that you'll aggregate, sum up, average, or etc. during analysis. So then, schemas in data warehousing. So schemas define how data is organized in a data warehouse. There are so many schemas types, but the two most common schemas are star schemas and snowflake schema when it comes to data warehousing. So in star schema, as you all can see, the central fact table containing the measures is connected to multiple dimension tables. It's simple and widely used uh, because of its straightforward design. So, for an example, a sales fact table might link to customer dimensions, time dimension, and product dimension. So, in a Snowflake schema, it's similar to the star schema, but with more normalization. The dimension tables are split into additional tables, which reduces data redundancy. For an example, a customer dimension table might be split into customer details, customer address, and customer contacts tables. Okay, so 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 today for this specific practical session, I will be using e-commerce data set called um, Olist. That was actually taken from Kaggle. So, so there I will be using this architecture when creating the data warehouse. So yeah, so now let's take a look at how to create SSIS package where we handle all those details. So let me open Visual Studio for that. So here also, like when you are installing Visual Studio data tools, like you have to make sure you have the data integration service and then analysis service, reporting services and everything. Then only you can work on this stuff. So at the moment I have used them, I have installed them, and let me create a new project for that. So for the integration, I'll just search for that integration service project. Next. And then you can give a name. I'll just give this demo and just give the locations and everything. Then you can create this. Right. So here you can see like here we have the all the options available, and here everywhere like you have the options. But here mainly we want connection managers. So connection managers are the places where we get all the sources connections, and then we have to create a SSIS package. So how we can do is this new SSIS package. So this is the SSIS package, like we can give it a name as well. And then we have the control flow, data flow, parameters and things like that. Mainly we are using this control flow and data flow. So in SSIS, control flow is where we set up the main step of our data process. It's like the project manage for your ETL task. So you define the sequence of actions like pulling data, transforming it, and the loading it in your warehouse. So you can use tasks like data flow to move the data around, and execute SQL to run queries, and file system task for handling files. It's all about keeping your data pipelines running smoothly. So you have all these options for control flow. Uh, yeah, so as mentioned earlier, like if you want containers, loop or anything, you just have to drag and drop like this. So then there's data flow. So if you click on this, then there's data flow coming up. Again, you can go back to the control flow by clicking this as well. So once the control flow task is created, we have to make sure the data flow, in the data flow also there should be a process. So in SSIS, data flow is where all the magic happens actually. It's where you move and transform data between your sources and destinations. So you will pull data from sources like SQL databases, Oracle databases, Excel files, and then use transformation to clean or modify it, like sorting, filtering, or merging. And then finally, you will load the transformed data into your target, like a staging table or data warehouse. Yeah, it's actually I would say, it's the heart of the ETL process, I would say. And it ensures data is shaped the way you need it before it's stored or analyzed. And then, yeah, so here, as I mentioned, like you definitely have to have a source. So for that, depending on what source you are using, you can drag and drop. So if it's a SQL Server database, you can actually go with ADO.NET source or ADB source. And then from there, you have to have a database destination as well. So that also you have so many options here. And other than that, all the transformation you do, you can get from here. Let's say you want to merge two tables, then you can just drag here and just do the merging part. So, and if you want to look up for some column, then just add this and do. If you want to create new columns or something, then you can add the derived column. So that is how this works. So let me explain. Let me show you something I've created before. So right. So this is. I hope you all can see my this package, right? And so this is the one I created for this Olist e-commerce database. So here I have two SSIS packages. One to load data from flat files to staging. So I think I did not show you all the flat files earlier. So let me quickly show that as well. So I have the data sets like this as CSV files at the moment. So that is what I'm using. So we need to get them to databases. So what I would do is um, I need to get the sources as a flat file from here. So in the sources, like you can get them as well. So and then you just have to give the connection properly. So for the connection, you can just give new, and then you just have to browse and show the location. Then it will automatically abstract everything. And also for the when creating the uh, columns and everything, it automatically uh, uh, identify what are the data types and everything, but always it's better to choose what you want. And then, so since we are running out of time, like I'll just go forward a bit faster. So then we need to import that to staging data warehouse, not the data warehouse database. Likewise, we can do that. So one thing I have to highlight is like when loading data into a data warehouse, there are several approaches like full load, incremental load, things like that. So full load involves reloading the entire data set from scratch each time, overwriting the previous data. So what I have done is this here. So, and then while this overwriting thing looks simple, this can be inefficient, and especially with large data set, it can be very inefficient. So when it comes to the incremental load, it is more efficient and is it only loads new or changed data since the last load, making it faster and uh, less resource intensive. So then there's batch load and delta load as well. So and also there's something like real time load. So that it streams data continuously into the data warehouse as it arrives, providing the most up-to-date data. But it requires more complex system to manage the constant flow. So each method has its benefits depending on the specific needs, such as the frequency or data changes, how quickly the data needs to update. So also, like you might have seen already, I have used truncate option everywhere, like truncate customer and then load, and then truncate geolocation and then load. So why truncate? So truncating and inserting data in staging means deleting the old data and loading fresh data each time. This keeps everything clean, avoids duplicates, and makes the ETL process faster and more reliable. And yeah, so the same way, I have I have the data warehouse package, which means like uh, staging to data warehouse loading package. And then we have yeah, so here we have dim product. Dim product means dimension product. So here I have actually put I have done some simple transformation. So we have this product table and then product category. Then what I wanted was I wanted to join them together as I mentioned earlier. So I have merge joined them. So this is the inner join I have used. I just had to pick what's the uh, key column that I need to use. So as I have marked, I have chosen what's the key column, and then I just need to I just need to tick on what needs to be carried forward. So here, that is how I have taken. And then I have done some derived column parts. So here, what I've noticed was when loading sorry about that, when loading data, um, there are some product IDs with inverted comma. So I wanted to replace all those inverted commas with uh, empty string. So I just wrote it like this. So that way we can do a lot of transformation here as well. So yeah, and then I have uploaded this to a data warehouse. So here also I have the connection knowledge data warehouse. And so as you can see, um, so we have actually, I think I did not mention properly. So here we have connection managers. So this is the staging connection. I have set the configurations to this SQL dev instance, so which is the local host in my computer. So, and then I have pointed this to this Olive staging database, and whenever you test the connection, it should work. If it doesn't work, then there's something wrong with that. And always make sure this provider should be native OLEDB when it comes to SQL Server databases. So here also it's the same. I have pointed this to data warehouse. So here I have set these connection managers to I have set these connection managers to package level, but also like we can make it to uh, project level as well. In that case, we can use the same connection in different packages. So we just have to right click on this and then convert to project connection. So that way we can handle that. And the other important thing is I'll show you. So when creating the data warehousing tables, so we use something called surrogate keys. So this is how this customer data is in the data warehouse, but I'll show you how it was there when it's on the staging table. Right. So if you check on this, like you can see all those inverted commas and the data are messy, but when it comes to here, you cannot see anything wrong here, like all are good. But again, I have added another extra column called customer SK, which means surrogate key. So when we are creating the data warehousing schema, this surrogate key concept is mandatory. So uh, so this is very important because like this the surrogate key plays a big role. So how data is structured in a data warehouse. So think of this surrogate key as a unique ID you give to each record in your database. But here the catch is like it doesn't mean anything outside the system. Unlike natural keys like product number or employee ID, a surrogate key is just a number that helps to keep things organized. So why do we need them? Well, imagine your data is constantly changing, like someone updating an employee's department or product names. Then, if we use natural keys, those changes would mess up the relationship between different data tables. So, surrogate keys let us keep everything stable and clean, even when the real world data changes. So, they also keep help in tracking historical data. So, if a product change over the time, you can store those different versions without getting confused. Basically, surrogate keys make sure everything stays smooth and flexible in a data warehouse. And also, there's a small thing I want to highlight. So we have something called um, slowly changing dimension. That is kind of an important thing when it comes to data warehousing. So when loading data into a data warehouse, we need to handle changes in data over time. But here I have not done that properly. But normally we can do that. We can use slowly changing dimensions as well. So type one just overrides old data with new data, which is fine if you don't need to keep history. Then there's type 2 SCDs. So this keeps a new row whenever data changes, so you can track history. Then there's type 3, keeps the current and previous values in new columns, useful for tracking one or two changes. And also there's a type 4, which stores all data in a separate table while keeping only the latest data in the main table. So this series method can be combined with different data loading strategies like full loading, replacing everything, or incremental loading, only updating change data. So each method helps keep the data accurate and up to date in the warehouse. I just wanted to let you know about that option as well. So so after creating all these ETL processes, the next important step in this scheduling is them to like run at the right time. So you don't want to manually trigger your ETL every time you need to fresh data. So so that we automate it. So scheduling ensures that the ETL jobs run at specific intervals, like every hour, every night, or whenever it makes sense for your data needs. So tools like SQL Server Agent and or Airflow are commonly used to handle this, making sure everything is run automatically. So this helps keep your data pipeline up to date without you needing to intervene every time. So it's all about efficiency and ensuring your data is ready when you need it. But here today, I won't be showing that part because we have a very limited time. So, and then let's talk a bit about some best practices as well. I know the time has passed, but I'll just let you all know because that is very important. So I'll share some tips that I've learned over the past years while working with these ETLs. First off, plan ahead. Don't just start right away. Understand your data source, where it's going and how it's going to get there. So a little planning can save you a ton of time later on. So next, keep your packages modular. Break down your ETL task into smaller, reusable packages. So this keep things organized and makes future updates or changes a lot smoother. So, and then always, always set up error handling. So you never know when something will go wrong. So make sure to have error outputs and logging in place. It's a lifesaver when things don't go according to plan. So all these options actually we have in SSIS. You just need to like find it properly and do it. Um, and then also use variables to store things like file paths, database names, things. So this keeps your packages flexible. If you ever need to change something, you won't have to go and digging through the whole process. You just need to change that specific variable. So it will change everything. So speaking of performance, optimize your processes. Don't let your ETL jobs run slow. Use fast load options and avoid transformation that block the process. So you want things to move fast. Also, do incremental loads, although I did not do it here properly, but do incremental loads. No need to load all your data every time. Only grab the new or change stuff. So as it will actually save you ton of processing time. So when it comes to incremental load, you can do it in many ways. So this also like you can just create a specific query and do as well. So here I have written a query. So that is from execute SQL query. So here also from using SQL query also you can do the same thing. So this is also you can do it. And then logging and monitoring is also very important. Track your ETL jobs so you can catch any issues early and fix them quickly. So it's way better than finding out something's broken days later. So keep it simple, don't overcomplicate things. The more straightforward your ETL process, the easier it will be to maintain. So stick up to these tips, and your SSIS ETL will run smoother, be easier and to maintain, and you'll save yourself a lot of headaches. Trust me, it works. Uh, then um, so then we have to discuss about SSAS as well. But before moving forward, I have another concept to explain before going there. So yeah. So what are multidimensional cubes? So imagine a data cube is like a dice. So when you hold a dice, you see six faces, each showing a different number. In the same way, a multidimensional cube in data warehousing organizes data across multiple dimensions like the faces of the dice. So now let's break this down. So as I mentioned earlier, the dimensions are like the axis of the dice. For example, if you think about a sales data cube, the dimensions could be things like time, product, and location. So each phase of the dice could represent data at the intersection of these dimensions, like sales data for a specific product in a specific region at a specific time. So, so the measures in the cube, which could be things like sales figure, profit margins, are are like the number of numbers you see on the dice. So these are the values we actually want to analyze. So when you roll the dice, you are essentially slicing the cube in a different ways. You can look at the sales for product in quarter 1 of 2023 in New York, or sales for all products in 2022 across North America. That is a great example. So actually, the beauty of this multidimensional cube is that they allow for fast dynamic analysis instead of running complex queries over and over again. The cube pre-aggregates data across different combinations of dimensions. It's like pre-slicing and dice into smaller pieces so that you can grab the information you need quickly without rolling the dice each time. So when we create a cube in SSAS, we are essentially building a sophisticated dice that can help us analyze and slice our data warehouse we want without the weight. So today we'll see how to create the cube really quickly. Um, so, so that is also for the analysis service we need. For that also we need to have Visual Studio and the relevant package install. So go and create a new project and then search for the analysis services. So when it comes to cubes, also there are two cubes, multidimensional cubes and tabular cubes, but here I'll be only discussing about multidimensional cubes. So great. Okay. So here, so when we are creating a cube, we need to connect it to a data source. We just need to create a new data source next, and then you like you can either create a new data source or you can use the same one. So maybe I'll just create a data source based on existing or new connection. So I'll just create a new one. Sorry. Okay, at the moment, like it will take some time, so we'll go with an existing connection. So this points to the uh, SQL dev Ollie's data warehouse. So we'll use that and then use service accounts. Finish. So we have the data source and then make sure to create a data source view. So we are getting the data warehouse database to here. and then create the data source wave. So here we have the connection. Next. So same name as primary keys. Then we have the tables that are available on the data warehousing database. So we can just get only what we need, but here we want everything. So I'm getting all of them together. Next, and then finish. So now we have all the data that are needed for us, and then we can create the cube. So then new cube. Next, use existing tables. So we have all of this. So if the data is good, when we tell suggest, it will suggest the measure group tables. But here it's not suggesting. So my measure group table will be fact order item. Then these are the measures available there. And next, and then we need to select what is required as well, and then finish. So in that case, we can get what we needed. So I'll show you something I created before. So for the same Ollie's data set, so I have created the source, and then we have the data set, data source wave. So here we have to make sure to uh, drag and connect all those surrogate keys, then the connection will build. It will help us to create the cubes very easily. So, so this is the cube. So we have our fact table. So we have our tables here, fact table and all the dimensions. Likewise, this is that we have the connections set up properly as well. So then if those dimension tables doesn't come here directly, you just have to create dimensions from here. So in that case, it'll be easier. Then again, you have to just make sure the link works properly. And then if you want any sort of measures, what you can do is you can go and create some new measures from calculations. So that is there. You have all the options for that. And if you want any KPIs, we can create from here. And also from this dimension usage, this is where we show all the links. So if someone wants some data related to seller and the order item, since we have the connection set up here, you can get that data. So if you want payment and order item, you can get the data. If you want payment and customer, you can't get the data because it's not connected. So likewise, we have that option, and then we just have to deploy from here, deploy the process from here. So then it will all show up on the SSMS. So here, as I mentioned earlier, we have database engine, analysis service, and integration services. So if we connect to analysis services, you can see this all this multidimensional cube that I have deployed earlier. And then this cube we can use to create maybe Power BI. Uh, we can create this source to a Power BI uh, presentation, or else to an Excel, or else for SSRS thing. So that way we can use, and also we can use SQL Server for them as well. I'll quickly show you how to connect that as well in Power BI. So this is Power BI, so I'll get a blank report. So if you want to get data from analysis service, you just have to click here and select the cube. In that case, it'll all show up here. If you want to get data from SQL Server, you just have to click here and then select what the exact database. So for the server name, you have to give this name properly. This is the server name. So it is So if you connect like that, you will get this navigator, and from here you can see what's the database you want. So normally when we come to this page, we are just using the data warehousing database. So here we can check like what are the data tables we want, and then load. If you want to do any transformation, we can do there as well. So So yeah, from there we can actually do everything. So I think it's clear. Uh, I'm not sure like whether you all understand what I said, but I hope like if you start to learn something from here, at least like you're familiar with the tools now. You have seen what we do there. So I think this will be helpful. So yeah, so do you all have any questions related to this? Any questions? Oh, things to clarify. Okay, someone had asked what Ascentic expect from a data engineer interns. That actually depends on the projects you have to work. So, mm, so basically, when it comes to interns, you just have to have the knowledge, but it always depends on what's the requirement. And there's another question: why do we use staging tables in ETL processes, and what role do they play in ensuring data quality and performance? So, that's actually a good question. So staging tables act as a temporary holder, I would say. So a place where we can load and process data before it gets stored in the main data warehouse. So they let us clean and transform the data, making sure it's in the right format. So using staging tables make the process more efficient and help us catch errors early. So only clean, accurate data gets into the data warehouse. So yeah, I hope that answered your question. So looks like there's no more questions. So if you all have any, so if you all have any more questions or anything, you can contact.
Through LinkedIn.
Yeah.
So Chamodi again, we have attached in the email. So you can look her through LinkedIn and send the questions to her directly, or you can email us as well. So thank you, Chamodi, for this insightful session, and thank you everyone for attending today's speaker session. This recording will be available in YouTube in the upcoming week, so stay tuned. Please also follow us through social media to stay updated on our next speaker, and we'll see you all in 2025. Thank you, everyone.